All right, imagine for a second stripping away the absolute biggest physical limitation of heavy machinery. For over a century, the golden rule of industrial engineering has been that moving parts create friction, and friction creates heat, wear, and hard limits. But what if we could just turn that rule off? Well, let's dive into this, because the answer to that exact question is literally reshaping global manufacturing as we know it. Welcome to this explainer of a massive, super high-stakes clash going on right now in the industrial world. Today, we're looking at the battle between traditional, age-old mechanics and a totally disruptive frictionless technology. We're going to compare conventional mechanical compressors, the grinding workhorses of the modern world, with the revolutionary power of magnetic levitation or Maglev systems. It is an absolute game-changer for industrial efficiency.
So, here's our game plan. First, we'll cover the friction problem. Second, enter magnetic levitation. Third, we'll put traditional versus Maglev head-to-head. Fourth, we'll look at industry applications. And finally, we'll wrap up with a sustainable future.
Part 1. The friction problem. The limits of traditional mechanics.
Look, traditional compressors are undeniable workhorses. They've basically built the modern world. They use a standard motor hooked up to a mechanical gearbox to drive a rotor. But here's the massive catch. They rely entirely on physical contact. We're talking metal-on-metal bearings constantly grinding together at high speeds. To stop those parts from literally destroying themselves, oil has to be pumped into the bearings non-stop for lubrication. It's a highly complex, highly physical system that just inherently creates severe friction and wear over time.
So why is all that physical contact such a massive roadblock? Well, first off, high friction severely limits your speed. Trying to run a traditional bearing over 20,000 revolutions per minute, or RPM, is incredibly demanding. It pushes the physical materials right to their absolute breaking points. Second, they're super prone to wear and tear, which means constant maintenance. Third, they need that never-ending supply of oil. And fourth, and honestly this is the real deal breaker for a lot of industries, there is a huge risk of that oil contaminating the pressurized airstream. That forces factories to install these massive, expensive filtration systems. Oil and friction are essentially the ultimate enemies of high-speed, pure air systems.
Which brings us to part 2. Enter magnetic levitation, the frictionless disruption. At the absolute core of this massive shift are active magnetic bearings, or AMBs for short. This is a system that uses electromagnetic fields to suspend a rotor entirely in midair, zero mechanical contact. You might hear the word maglev and immediately picture those crazy high-speed levitating passenger trains, right? Well, it's the exact same fundamental principle, but instead of linear propulsion moving a train forward, we're applying it to rotational motion inside a machine.
Let's actually look at how this magic works in practice. Step 1. The maglev bearings, both radial for side-to-side stability and axial for forward-to-back thrust, use electromagnets to suspend the rotor perfectly in a magnetic field. Position sensors are watching it in real time just to keep it totally centered. Step 2. A high-speed permanent magnet motor drives that floating rotor, turning electrical energy into kinetic energy with barely any loss. Step 3. A centrifugal impeller spins, sucking in air, accelerating it, and dynamically compressing it. It is just so incredibly sleek compared to those clunky, oily gearboxes we were just talking about.
Moving on to part 3. Traditional versus Maglev, the head-to-head comparison.
Let's put these two right next to each other to look at the fundamental differences. On the mechanical side, you've got physical bearings. They absolutely have to have oil lubrication and they demand frequent maintenance because, well, the parts are physically grinding themselves down. Now, on the Maglev side, you have electromagnetic bearings. Because there's literally zero physical contact, they are 100% oil-free, and they require minimal maintenance. So your golden rule of 3 here is this. Maglev is frictionless, it's completely oil-free, and as you're about to see, it is ridiculously efficient.
When you look across every key operational metric, it's honestly not even a fair fight. Take maintenance, minimal versus frequent. Or look at noise and vibration. Because a maglev rotor isn't physically rubbing against anything, the vibration is virtually eliminated. It makes it incredibly quiet compared to the noticeable roar of a conventional system. And under air purity, Maglev guarantees a 100% oil-free environment, whereas conventional systems always carry that lingering risk of contamination. Across the board, Maglev just dominates.
But, if you want the real reason industry executives are suddenly paying very close attention, it boils down to this number right here, 30%. Because Maglev deletes mechanical friction and uses these highly intelligent speed controls that adjust to real-time demand, energy consumption just plummets. Facilities are seeing up to 30% energy savings over their conventional mechanical setups. I mean, over the course of a year in a massive manufacturing plant, that is an unbelievable reduction in operational costs.
Okay, part 4, industry applications. Why massive industries are shifting.
Before we even get into the specific industries, I just have to drop this mind-boggling number on you. 100,000 plus RPM. Remember earlier when we said traditional mechanical bearings hit a wall and really start struggling at just 20,000 RPM? Well, when you completely delete physical friction using Maglev, some specialized variants of these motors can spin at over 100,000 revolutions per minute, or even higher if they're in a vacuum. The performance ceiling just shatters entirely. And this exact capability is why so many totally diverse fields are adopting this so fast. In semiconductor manufacturing, they use turbomolecular pumps that achieve high vacuum environments with zero contamination. That's absolutely essential for making microchips. Over in the medical field, Maglev is literally saving lives. The HeartMate 3 blood pump uses a bearingless motor to deliver consistent blood flow for over a decade without mechanical failure. In food and beverage, factories are seeing 60% less noise and 40% less maintenance. And in pharmaceuticals, Maglev provides the completely sterile, oil-free air you need for strict good manufacturing practice, or GMP-compliant production.
Finally, part 5, a sustainable future, the bigger environmental picture.
The environmental payload of this technology is massive, because these machines don't waste tons of energy just trying to overcome their own internal friction, and because they don't require you to produce, use, and throw away industrial lubricating oils, they are vastly greener. Many industries are actually reporting a staggering 40% reduction in their carbon footprint after making the switch from traditional systems over to intelligent Maglev compressors.
Plus, we definitely have to talk about longevity. Because of the contactless design, there's virtually zero mechanical wear and tear. You just have this pristine rotor hovering in a magnetic field, and built-in IoT sensors are constantly predicting potential faults, which allows for predictive maintenance long before anything actually breaks. Thanks to all this, these Maglev compressors often hit functional lifespans of over 20 years. That is an incredible return on investment when you compare it to having to replace ground-down mechanical parts every couple of years.
To really summarize the true significance of everything we've talked about today, I want to share this quote directly from the source material regarding these Maglev centrifugal air compressors. It's more than just a machine. It's the future of sustainable industrial production. We are literally moving from an era of grinding, oiled, high-maintenance mechanics into a totally new era of fluting, clean, intelligent efficiency.
So I'm going to leave you with this final thought to chew on. We've seen how this technology is transforming everything from the microchips inside your phone to life-saving medical devices. As friction literally becomes a thing of the past in modern manufacturing, how will Maglev technology change the products you use every single day? Think about that. Thanks so much for joining me on this explainer, and keep learning.